We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org. Hey, it's Alex Williams, the new stack here at Cloud Foundry Summit in Frankfurt, here with my co-host, Job Jackson. Hey, Job.
Hello.
And Idit Levine. Hey, Idit, how are you?
Hey, great. Good to be here.
It seems like we see each other at shows more often, and we didn't make it though to the spring conference, and there was some news that came out of that I thought was pretty interesting about Unikernels and the kind of the next iteration that you guys are working on.
Yeah.
Can you tell us about that?
Yeah, so I mean, we continue working constantly about the project that we did, which is Unik. In Spring Boot, what we did is, first of all, when we did the integration of Unikernel with Cloud Foundry before, the implementation was kind of like that we needed to change code. It was more complicated. What we did for Spring Boot, we basically find a way to do it as a build pack, which means that you can just basically choose whatever Cloud Foundry you have, the regular distro that is certified by the Cloud Foundry Foundation, and just use our build pack, and you will be able to run Unikernel and get the same way you're running your container, exactly the same way. So,
what would you do with a Unikernel in a Cloud Foundry platform?
So I mean, Unikernel is a good deployment tool, right? I mean, basically it's a way to package your application, and you're getting better performance and security and so on. What's special about Cloud Foundry is that Unik, the tool that we created, is basically like Docker in terms of where it's in the stack. It's basically will create you the Unikernel, it will build it to you, it will run it on the provider, but you will never you will not monitor it, right? I mean, if you lose it, you lose it. The advantage of what we can do with something like Cloud Foundry is just the ease of the development experience. You can actually leveraging quality like the Go routers and the services that Cloud Foundry is giving you, the health. So to monitor if one of the Unikernel is dead, they're going to spin up a new one for you, and so on. So basically, we're just leveraging the cluster management past experience to Unikernel. So that's why we're using Cloud Foundry.
The cluster management.
Yes.
Okay.
As well. And we also support I'm going to be also in KubeCon, which is the Kubernetes conference.
Right.
And we're going to talk about Unik back then. And also what we're doing there, which is very cool, is we basically integrated with Kubernetes. So we're going to do a pull request for that. And it seems that the community is very excited about it.
Hey, wait, how does that work?
So the way Kubernetes is working, you basically have kind of like a runtime backend, and today you're supporting Docker and you're supporting Rocket, and what we did, we basically added the integration with Unik. And we also have Unik Hub, which is like Docker Hub. So the way Kubernetes is working is that you're not building it in Kubernetes, you're just running it with Kubernetes. Sure. And usually you're doing it by using the Docker app or whatever app you're using. We have right now Unik Hub, which means that you can actually share Unikernel between the community. So we will use that, we will leverage that, and we're going to run Unikernel. So in a pod, you will have a VM basically instead of container.
So I could run a whole pod of Unikernels,
yes.
Basically.
Yes.
All right. And that would be, I guess that would be a way of setting up would that work with microservices? I mean, is that good for filtering, like you have one Unikernel handling one function, or what's the best way to think about that?
So exactly, Unikernel is basically a single process, right? Single address space, which means that you can run only one single, which is working very nicely because this is what you're doing anyway in container, right? Usually you're running one, mostly, right?
Yeah.
If you're doing the right microservices architecture. So that's basically the idea. You're anywhere running one process, so you can run it in VM, and you're leveraging a lot of the maturity of it, of the security of it, in the fast boot time, and so on. So yeah, that's basically the idea. And Yeah, I think it's really cool. I mean, another cool thing about it, for my opinion, is the fact, and that's true for Cloud Foundry and for Kubernetes, is that today, if you want to run your container, you need, first of all, a host. You need some VM or something. With Unik, you don't. You basically scale out automatically, because basically you're scaling out VM. It's just very, very fast boot and small VM, but they are VM. So basically you don't need Cell, for instance, in Cloud Foundry, or you don't need a host for a Kubernetes. Just on the main, you're spinning up and spinning down basically the VM, which is basically the Unikernel. So it's interesting because you don't need to care so much about the environment before you actually want to deploy.
What's the orchestration for that then?
So what we're doing, the way Unik is doing, is that there is three things that we need to know when we compile a unikernel. The first one is the language. That's easy. The second one is basically which unikernel type you choose, because we're supporting OSV, Include OS, RAM kernel, Mirage OS. We're going to add support right now. We're just actually going to release Solo 5, which is an IBM research.
Okay.
So you need to choose which one you want to build it as. And the last one is that you need to tell me where you want to run it, because we're a little bit more than Docker. We also basically run it for you on the infrastructure as a service or bare metal. So what we're going to, and for that we're supporting OpenStack right now, full support for OpenStack, for vSphere, for QEMU, KVM, VirtualBox, just name it, Zen, so AWS. So basically that's the way we're scaling it up. We're just talking directly to the for instance, to vCenter and spinning up a machine. But we're doing it automatically as part of the packaging and deployment. Make sense?
So there's still lots of, it seems like unikernels hit like this, like they seem like he hit a chord with people. Like there's it's almost like a nerve ending or something, like, the unikernels comes up and people have all kinds of opinions, right, about it.
Yes.
Right. And
including some of your peers at EMC.
Yeah, like Randy Bias wrote a story for us on this, and it got a lot of actual, there were a lot of people who say, actually there's a lot more deeper angle to this than
we're curious about that. He was saying that they're not, unikernels are not secure because you're running at ring 0, and I'd love to get your feedback on what.
This is not accurate, right? It does accurate that we're running it on ring 0. That's true. What is not accurate is that it's not secure, because let's think what you can actually do if you're running on the. Why do we have the layers in the machine? Why do we have the rings? Why do we have multi-use address space? The reason we have that is to protect processes. So let's say that I'm running 2 processes on my machine. One of them you're running and one of them I'm running.
Right.
If yours is in trouble, I want to make sure that it will not influence mine, right? That's the reason I need to make sure that I cannot actually run in kernel mode and destroy the machine itself, because then you're hurting my processes.
Sure.
But the beauty of unikernel is that you're running one processes. That's it. So let's say that I'm running my process on a unikernel and I actually managed to die, right? I managed to kill the machine. Yeah, the VM is dead. You know what? Your application is dead anyway, even if you're running in your container. Yeah, so you will use your application exactly like you will use it in container. The big question is, what is the difference, for instance, if I'm running right now Linux operating system with container versus hypervisor with a Linux container, because that's really the difference. And what I will argue that unikernel is more secure because the hypervisor is giving us what called a hardware isolation, right? There is in the chip itself, there is a way to do a basically physical isolation, which is better than what you're getting from the Linux operating system. So what I'm saying here is that definitely you're not going to get worse results if you're running in a unikernel in a ring 0. You probably will lose your application. You will do that also if you're running in container, not in ring 0. You're just going to lose your application. And because there's one process, it doesn't really matter if you're losing the VM, because the VM is the application. So if you're losing the application, you're losing the VM, but who cares? You're not running anything out there. So basically what I'm saying is that it's at least as secure as running container or VM in not ring 0.
Nice.
Does that make sense?
Uh-huh. Okay. And also another critic not against the work you are doing in particular, but the idea of unikernels in general, is Brian Cantrell over at Joyent. And he had said a couple of things. He had said, well, there are security problems with hypervisors, but he also had made a lot about the lack of debugging capabilities.
So, way back when containers started, I can show you a lot of articles about people saying the tooling should be different, right? Before that we were using an agent for Puppet, now the deployment it will be different. Before that we put a user of Splunk, again, will not make sense in container sense. You need to take the logs from the container themselves. Okay, what did we do as a community? We built a new tooling. That's exactly what will happen right now. So now the question, if there is any technical problem, a reason that I will not be able to do that. And the answer for that is no. We building Unik, in order to build Unik, we had to debug the Unikernel. We just didn't automate it yet. We started, by the way. You can today get all the logs of Unikernel. For instance, I will show tomorrow a demo that I'm running Minecraft on Unikernel, and I will show the logs of the Minecraft, right? Because Unik do that. What I'm trying to say is that you definitely can see the logs. We also are supporting a touch debugger for running on QEMU. We can do it on every other hypervisor. We just didn't have the time because I don't have enough resources. But what I'm trying to say, yeah, you need to do a new tooling, but there is nothing that really, a technical issue to do that. You just need to go and do it. And we will. We're just taking time.
Perhaps he's just angry that you can't use dtrace, I guess.
That's true. So you can do something like dtrace. We can do that. We can do that. We are not in a... So we are not worried at all. We just need the time. It's just not the first thing on our priority. But we will do that. We definitely will. We know how to.
Terrific.
Fair?
What are you seeing with adoption right now for unikernels?
So that's interesting. So we open source Unik 3 months ago, I think. It was in VMworld. We didn't do any crazy press release. I mean, I think the EMC did a very easy one, small one. But after it, basically, I'm in the marketing person, and I'm tweeting, but we aren't doing much in order to kind of spread the word, except of talking in conference because the talk got admitted, and tweet a little bit about it. We have right now, I think, around 900 stars in the repository, which I feel kind of like very, very impressive. We have a community that contribute code. We have close to 100 people watching the repository constantly. We have a Slack channel that people are active, asking questions, and helping us to make that better. And we have a Twitter account that actually people follow. So I feel that it's going very well. Again, specifically because we didn't do much, right? It's only me doing some marketing, which I'm not a marketing person. So other one, I think that it's going very, very well. And I said, I think that if we will have more push from the, for something bigger behind us, like Linux Foundation or Eclipse Foundation behind us, it probably will be better. But other one, I think that it's very interesting.
Now, is Unik within EMC? Is this? I guess it might be too early to tell, but is this something that could possibly be commercialized in-house, or is it a proof of concept, or are you putting the code out there and maybe allowing third parties to commercialize it?
It's a good question. I mean, EMC was busy a little bit right now merging.
Sure. Yeah.
So we are looking to see what we can do in Unikernel, specifically inside, existing product in EMC. I don't know. It's really only start talking about. But I think that theoretically we can. There is a use case to put it in storage devices.
Oh, yeah. Makes sense, yeah.
But again, it's only like future thing.
Sure.
But besides that, EMC, I don't think, at least the purpose of me doing Unik wasn't to make it was a very good technologies. I'm good and innovative, and the idea was EMC really, really good and innovator, and they can put it out there and make a community around it. That's it was more like we want to play, not more than this.
Nice.
And I'm a big believer. I do believe that Unikernel will be. There is a huge place in the future of cloud and Internet of Things for Unikernel. I really believe so. So, I'm going to do anything I can in order to help that.
What are some of the IoT patterns that you're starting to see emerge with unikernels?
So there are not a lot. I mean, we did most of them. What we did, and we're going to open source it, we basically put Unikernel on Raspberry Pi. There is people on the Slack channel that basically had some crazy idea, like for instance, to make a keyboard that is on demand with a Raspberry Pi behind it. There is someone had an idea to create a phone from Raspberry Pi, and a lot of other crazy stuff like this.
So what is the unikernel role in something like that?
Mainly it's in terms of architecture. When you're running on Internet of Things, usually you don't have a lot of space. You want the device of Internet of Things, the thing to be small.
Right.
Which means that you don't have a lot of storage. It doesn't make any sense to run a full operating system. That's what today people doing.
Right.
And if you're running only one process, probably you will get much more performance, security of course, and space, memory, to actually run unikernel. So it's just better use case, better architecture to run something in an Internet of Things. That's why we think that that should go there. And in terms of, what are you benefit from it? As I said, mainly security and performance, and the fact that it's very small.
So you could build a device, for instance, without root access, for example, that then allows
You're running the unikernel itself on the embedded device. There is nothing between, right? The beauty of it, so like today, you have two options. You're running a kind of like, I think it's a Raspbian, which is the Debian for Raspberry Pi. It's a full operating system. Then you're running whatever, if you want Docker, you're running Docker on top of it. That's not really performable and it's taking space. With Unikernel, you basically only have the driver that you need and the code running directly on the chip.
Right.
So it's very, very fast and very small.
Is that going to be a primary
Use case?
use case is embedded systems?
I believe so. This is my opinion. I mean, to be fair, there's also Arduino and stuff. They don't really have operating systems. So I guess, it depends what you need for. I believe that it's definitely going to be a use case for unikernel there. The question is, what will be harder in terms of the embedded device itself. But I believe that if you will need an operating system, and if you will need something to run, for instance, on Raspberry Pi, and it will be one process, it's definitely going to be the unikernel. And I think that that's what will happen. That's, again, it's just, you mentioned people that are arguing about the cloud option for unikernel. People have their own security. There was, they're afraid from the security or from the debugging. No one that I talked about argue about the Internet of Things use case. Everybody agreed that this is a perfect fit.
What's the difference? So there's a use case people are starting to talk about with containers in the Internet of Things as well.
Yeah.
There's never going to be one or the other, right? I mean, or do you think the unikernels will just be the dominant environment?
I believe that eventually it will. Again, it's all about use case. You're not going to run Docker on Arduino. So
right.
we're all talking about Raspberry Pi. And in Raspberry Pi, if you want one process, you should go with unikernel. It's just the best one. If you want multi, for some reason you're running, on the gateway and you want to run more than one application, then you probably will use Docker. Because Docker is just a wrapping tool, right? It's like, it's just wrapping your application. It's a deployment tool. So if you have to choose something to deploy it, then you cannot use the unikernel model because you want to run on the one processor, so you will go with Docker probably.
How would that fit within like an event-based architecture from services that we're seeing, such as Lambda or
So unikernel is very fast to boot because there's not a lot to boot there, right? Basically, it's a bootloader and you're jumping there, and then you don't have a lot of lines of code to actually run because it's only basically the drivers and scheduler and memory management. That's it. Therefore, it's very fast to boot. Today, in a architecture like Lambda and a function architecture or serverless, the way it's working, it's basically the reusing container because the boot time is taking time. So the way to get a really speedy boot time is basically just use something that exists. So they're taking a container and they reuse it. And this is what IBM doing right now. This is what AWS Lambda is doing right now. Basically reuse of container. That's an interesting model. I believe that Unikernel can fast boot, very quick, right? So that's not an issue. I believe that they are very secure because you will actually run one server function. You're not going to share it and reuse it. And again, mainly the option that it's very fast to boot, so that's a perfect fit again, right?
Right.
And also don't forget it's function, right? So it's very small, usually one processor. So you're running a function, you're not running more than one. So again, it's a very good use case.
How do you, looking down the road when lots of cloud providers or lots of IoT equipment providers have many unikernels and many variations of unikernels, do you see the ability to manage them at scale, even though there may be a lot of configuration changes across them?
Yeah, because I think that is what Unik make it very easy for you, right? I mean, it's an orchestration tool in the end of the day. It's very hard. When I was 2009 in Dynamic Coop, which is Dynamic Coop was a startup that got bought by VMware, was doing class management. It's what vRealize is today. When we did that, we had the same. So we tried to solve the same problem, right? There is a lot of variation of VM. We need to make sure that there is no, VMs that you're not using because it's easy to spin up. That was the same problem. I believe that the layer for it will not be unique. Unik, it's like Docker, it's nothing, right? I believe that the layer above, something like Cloud Foundry, something like Cluster Manager, we will need to run it. But in the end of the day, you're taking your code, you're telling me what you want to do with it, you're doing it, it's immutable, you don't want it, you kill it, you want it, if you want to update it, just kill it and create a new one. So it felt to me that there is not a lot to manage, and Unik is the one who's managing it, so
So the developer platforms then could theoretically be the Cloud Foundry, Kubernetes,
everything that Docker is working with, right?
Right.
Yeah.
Eclipse.
Yeah. Everything. And more than this, also .NET, right? One of the things that we want to do, we're working on it right now, is basically run .NET inside Unikernel. And the reason we want to do that is because so Microsoft make .NET working already on a NetBSD, which means that it's easy for us to do it running on something like ROM kernel. This is a market that actually will appreciate the DevOps because they are not influenced from Docker as much as probably Docker will wish. And also that means that you don't need to pay a license, which means very interesting, right, model. So you can run it, you get crazy performance, security. And more than this, if we will support on ROM kernel something like C#, the way the Unikernel is working, you have the drivers and you have the language itself. If it's basically separate. So if we actually supporting embedded device and supporting C#, you can be a developer that writing C# and actually running Internet of Things for Raspberry Pi, which is an interesting thing, right? So you basically run Go or C# or whatever you want for Internet of Things very easily. So I think it will be a very interesting market opportunity.
Well, Idit, thanks so much for joining us.
Thanks so much for
always
having me.
interesting to talk with you, and we look forward to following up real soon.
Awesome. Thank you so much for having me.
Thank you.
Thanks.
We'd like to thank Cloud Foundry, our sponsor, for these podcasts from Cloud Foundry Summit in Frankfurt, Germany. Cloud Foundry gives companies the speed, simplicity, and control they need to develop and deploy applications faster and easier. It's open source, easy to iterate, and built to scale. Learn more at cloudfoundry.org.